What is the largest area of the rectangle inscribed in an ellipse? So the ellipse is given by this equation. For this problem, you may take for granted that the optimal rectangle is not tilted relative to the axis. You may assume that the rectangle with the maximum area must have its sides parallel to the x and the y-axis. So let's draw the picture we have. So here's our ellipse, 3 and 4. The equation, this one. So here's 3 and 2. And we have a rectangle. Now we compute the area of this rectangle. So for this question, you may assume that they are parallel to the x and the y-axis. So say the point in the first quadrant here has the coordinates x, y. X here, y here. So you see that one side of the rectangle has length 2 times y, then one side of the rectangle has length 2 times x and 2 times y. So each side has length 2x, 2y, and x and y are length, so they are positive in this case. The area of the rectangle, let me denote by a, is 2 times x times 2 times y, 4 times xy. We need to maximize it. So here's our relation. Usually I can get rid of one variable x and y. By this equation, I can rewrite x and y and take the derivative. But that requires we need to use all the square root. To avoid that, here's one method. Method 1. From the relation we have here, from this relation, get rid of, say, x or y. Write x in terms of y, say, as a function of y. So we know that this could be like square root of x squared over 9 equal to 1 minus y squared over 4 x squared, 9 times 1 minus y squared over 4. Square root both sides, x positive, so get rid of that absolute value. 3 square root of that. So you see that there is square root here, which we don't want to compute with the derivative when we find the maximum area. Then you compute a as a function in y. You have the domain for y. You find a prime of y, find the critical point. Take the first derivative test. Compute the table. First derivative test. That's what we did. Find y so that a of y is max, and then compute it. So that is a general strategy we usually use. In this case, let me rewrite this ellipse a bit so that we don't need to use this square root. This ellipse, actually, we can rewrite it as this form. divided by 3 square, y divided by 2 square equal to 1. So see that something square plus something square equal to 1. So that something x equal to 3, we can put it as cosine. Y equal to 2, you can put it equal to sine or theta. And remember that our x and y in the first quadrant. So x over 3 bigger than 0, y and y over 2 bigger than 0. So both sine, cosine bigger than 0. So our angle theta between 0 and pi over 2. So x equal to 3 times cosine theta, y equal to 2 times sine theta. So this is our new variable. So we have one variable. Instead of x, y, I rewrite all that with theta. So now we have theta equal to this, x and y equal to this. I can rewrite the function area. Area equal to 4 times x times y. So our objective function area 4xy 4 times 3 cosine theta 2 times sine theta, which is 12 times 2 sine theta cosine theta. I save this 2 here because I know that cosine times sine is equal to sine 2 theta. So this is area, a function in theta. So now here's, we see that sine is always less than or equal to 1. So this one's less than or equal to 12 times 1. So maximum is 12. The area gets maximum is 12. And the equalities, or max A, is 12. And this happens when if sine times sine up 2 theta equal to 1. So this is the condition. Equalities when this one equal to 1. Sine equal to 1. So here's our unit circle. Sine equal to 1. So it should be here, which gives us 2 theta equal to pi over 2. Theta pi over 4. So we have area's maximum equal to 12. This is actually our final answers. Maximum is 12 when theta is pi over 4. So the question they asked us, what is the maximum area? And we can answer is 12. If they asked us what x and y would it be, then you plug in the formula here. X 3 times cosine theta cosine pi over 4. Pi over 4 theta here, so we have square root 2 over 2 root 2 over 2 3 root 2 over 2 and 2 sine pi over 4 2 root 2 over 2 root 2. So you see that 4 times xy, x times y equal to 3. 4 times xy equal to 12, which is the maximum area we have. Now one remark, you didn't see me computing a prime. Usually we have the objective function, we need to compute the critical point. That actually hidden inside here. This is our objective function. So remark or note. So theta between 0 pi over 2. So usually we do a prime theta. So 12 sine prime 2 cosine 2 theta. This one equal to 0 if and only if cosine 2 theta 0. Cosine equal to 0. So you see that we are here. Or here, but we are in the positive for that. So we are at this point 2 theta pi over 2 theta pi over 4, which is the point we have here. This is a max at pi over 4 here. But for the first critical or first derivative test, you draw a table like that, usually theta 0 pi over 2, and we have critical point pi over 4. A prime get 0 here, cosine of that. So theta between 0 to pi over 2, 2 times theta, that's angle here, this angle between 0 and pi, just multiply 2. 0 and pi, we have this one. 0 and pi is 2 thetas, start from here and end at here. So you see that it is positive this side, negative this side. So this one gives us, or I can write down as here, 24 cosine 2 theta. 24 cosine 2 theta. It really depends on the side of cosine 2 theta. And it is negative if it is on this side. It's positive if it is on this side. So positive here, which means that it's run from 0, 2 thetas run from 0 pi over 2, or theta between 0 pi over 4, then it's positive here. And negative the other side. If it's run from here to here, negative side. And because of that, a theta increasing here, decreasing here. That's why maximum happens right here. A theta is max when theta pi over 4. So a theta, max a theta equal to a at pi over 4. Area, this formula. So this gives us 12 times sine 2 times pi over 4, pi over 2. 12 times 1 equal to 12. So that's why it's maximum equal to 12, which is as we said. So I don't know whether it's worth it to change it to trigonometry, whether you like to do all of these radicals or square root function, or you like to do it with theta. But either way, we should have max area 12.